All right, let's talk about one of the most famous, most frustrating phrases in all of software. It's a problem so fundamental that solving it literally changed everything about how we build and ship applications. So let's get right into it. Ah, yes, there it is, that sentence. If you've ever worked in tech, you've heard it, you've probably said it, and you've definitely felt the frustration on both sides of that conversation. We're going to treat this phrase as the main villain of our story today, because once you understand why this happens, the solution feels like pure genius. You see, this isn't just some developer excuse. It actually points to a massive, systemic crack in the foundation of how we used to do things. When an app runs perfectly for the person who built it, but then completely falls apart the second it moves to a production server, well, that means the process itself is broken. The fix wasn't a patch, it was a total revolution.
So what's really going on when someone says that? Well, the culprit has a name: environment inconsistency. It's a fancy way of saying that the computer where the code was written is different from the computer where it's trying to run. And those differences, no matter how small, can cause absolute chaos.
And you know, what's wild is how predictable these failures are. It's almost always one of these usual suspects. First, you've got language versions. Maybe your app needs Python 3.9, but the server is still running 3.7. Boom, it breaks. Then, there are missing dependencies. All those little helper libraries your code needs, if even one is missing on the server, the whole thing comes crashing down. And of course, the classic connectivity problems. Firewalls blocking access, the wrong password for the database, you get the idea.
So, how do you solve that mess? The answer is this incredibly simple but powerful idea called containerization. The thinking goes like this: instead of just shipping the application's code, what if you could package up and ship the entire environment right along with it? That simple question is the strategic breakthrough that changes the whole game.
Let's just pause on this definition for a second, because this is the core idea. Containerization takes your application and bundles it with everything it needs to run. I mean everything. The code, the right language version, all the system tools, every single library and dependency. It all gets shrink-wrapped together into one standard, self-contained unit. This guarantees that the environment is perfectly identical everywhere.
To make this super simple, just imagine you're providing lunch for 100 people. You could hand out the burgers, then the fries, then the drinks, one by one. But you know that's going to be a mess. Someone will get the wrong drink, someone else won't get fries. It's just inefficient. The smart way, of course, is to pre-package a complete meal for everyone. A software container is exactly like that pre-packaged meal. It ensures everyone, or in this case, every computer, gets the exact same complete and correct setup. Now, as good as that lunch analogy is, the real-world inspiration behind this idea is even bigger. It's an idea that had already changed the world once before. Back in the 1950s, the global shipping industry was pure chaos. Trying to load cargo of all different shapes and sizes onto a ship was slow, expensive, and a logistical nightmare. And then, someone invented the standardized shipping container, and it revolutionized global trade as we know it. The first huge benefit was flexibility. Suddenly, it didn't matter if you were shipping TVs or coffee beans or cars. Everything went into the exact same type of box. And for software, this is a game changer. It doesn't matter what your app is written in or what it needs to run. It all gets packaged into the same standard container. How amazing is that? The second benefit was a massive jump in speed, in velocity. Because every container was the same size, you could build specialized cranes and ships to handle them with incredible efficiency. Loading times just plummeted. In the software world, this translates directly to deployment speed. We can move and start applications way faster because the packaging is universal. And of course, whenever you get that kind of efficiency and speed, you know what comes next: lower cost. The cost of handling and managing all that cargo dropped dramatically. In the exact same way, containerization lowers the cost of deploying and managing software, because the whole process just becomes so much more streamlined and predictable.
And this slide right here, this is where it all clicks. The story of software perfectly mirrors the story of shipping. You had the same problem, dealing with inconsistent shapes and sizes. You got the same solution, a standard container, and you got the same result, a complete revolution of the industry. This is the big why behind it all. Okay, so we've spent a lot of time on the why because it's so important. Now that we get it, let's switch gears and talk about the how. The main tool that everyone uses for this is a platform called Docker. Let's break down how it actually works. You know, the process itself is beautifully simple. It's a clear three-step flow. First, a developer writes a simple text file called a Dockerfile. Think of it as a recipe.
Second, you use that recipe to build something called a Docker image. And third, you launch a live running container from that image. That's it. Blueprint to template to a live application.
This building analogy is the perfect way to grasp the difference between these parts. The Dockerfile is the architect's blueprint. The image is like a prefabricated building made from that blueprint. It's got everything inside, but it's just sitting there, static. The container? Now that's the occupied building. It's been placed on a foundation, the power is on, and things are happening inside. It's the live, running instance. And this is so important. A container isn't just code. It is a live process that includes the runtime, the tools, the libraries, everything.
Okay, so we have our application running perfectly inside its little isolated box. This is great, but there's a catch. How does anyone from the outside world actually use it? And that brings us to networking.
Right? This is a really good question. By default, a Docker container is completely sealed off. It has its own little private world that no one else can see, which is great for security. But we need a door. So how do we build one?
The answer is a clever trick called port mapping. It's really just a forwarding rule. You tell Docker, hey, see port 8080 on the main computer? Any traffic that shows up there, I want you to send it straight through to port 5000 inside this specific container. It's basically a bridge that connects the public world to the private world of your container.
Probably the easiest way to think about this is the receptionist analogy. You can't just dial a specific employee's extension from your cell phone, right? You have to call the main company number first. The receptionist then connects you. Here, the host machine's port is that main reception number. You make a request there, and the receptionist, Docker, patches you through to the right internal extension, which is the port inside the container. Simple and effective.
So, we figured out how to run one container. But let's be real. Most modern apps are more complex than that. They're usually made of multiple services that all need to work together, like a web server that needs to talk to a database. How do we manage all of that? Well, you could try to start each service manually with a bunch of long, complicated commands, but that would be a nightmare. It would be super easy to make a mistake. So instead, there's a much better way, a tool called Docker Compose. You just describe your entire application, the web server, the database, how they connect, all in one simple, human-readable file. Then, with a single command, Docker Compose brings the whole system online, perfectly. So let's just pause here and recap everything. We've journeyed from this incredibly common problem to a revolutionary idea inspired by shipping containers and all the way to the specific tools that bring it to life. This really does represent a whole new era of building software. So, if you're going to walk away remembering just a few things, let it be these four. 1. Docker and containers solve the "it works on my machine" problem with standardization. 2. The workflow is simple: blueprint to template to live application. 3. Port mapping is the friendly receptionist that connects the outside world to your app. And 4. Docker Compose is your magic wand for managing applications with multiple services. And really, that brings us to the final, most exciting thought. The whole point of this technology is to remove the friction, to make your application truly portable so it can run on your laptop or a server down the hall or on any cloud provider in the world and behave the exact same way every time. So the question is no longer if your application will run, but simply, where do you want to run it?